We're going to look at this problem and do a normal approximation for binomial distribution using the large counts condition. And here we got 2,500 adults that we want to see if they agreed or disagree with I like buying new clothes, but shopping is frustrating and time consuming. So what we want to do is we want to show that x is approximately binomial random variable. So binary, we're going to use bins. So we need successes and we need failure. And to define a success, we'll go ahead and agree that shopping is frustrating. And a failure is don't agree. So we got the B part down. The next part is going to be check independence. Well, the trials are not actually independent. The conditional probability actually changes without replacement. So technically they're not independent, but are the numbers large enough to actually work? So what we need to do is check the 10% condition, and the 10% 2,500 is much less than 10% of all U.S. residents. So therefore, by the 10%, do we have a fixed number of trials? And what is our probability of a success? Well, we're supposing that's 60%, so it's 0.6 that it's going to be your success. The next thing we need to do is we need to go ahead and check with the large counts. So what we need to do is we need to check these conditions up here. And if you do 2,500 times 0.6, is that greater than 10? It's going to be 1,500, and of course that checks out. And the last one, 2,500, 1 minus 0.6 needs to be larger than 10. And so that's going to give us 1,000 is larger than 10. So sure enough, that as well checks out. So the next thing we need to do is, so we check the condition for using normal approximation in this setting, and now we're going to use a normal distribution to estimate the probability that 1,520 or more of this sample agree. So since we want to use a normal distribution here, let's go ahead and make our curve. And with a normal distribution, what are the two things you always want to find? You want to find the mean and the standard deviation. The mean, if we know our probability, we could go ahead and do 2,500 times our probability, and what we will do is we will get a mean of 1,500. And the next is we need to go ahead and find our standard deviation. If you remember standard deviation, and our standard deviation is going to be 24.49 if you do that math. And so now what the question is asking is, it says, what is the probability that we get 1520 or more? So this is 1520, and we want more, so what we're going to do is shade to the right, and this turns into, hey, let's find the z-score. And if you find your z-score there, turn that into a probability, and it's 0.7939. But remember, z-scores will always give you the probability to the left. So you need to do 1 minus 0.7939. And that will go ahead and give you 0.2061. So that is saying we have a 20.61% chance of getting a sample in which 1,520 people or more agree with the statement that they like buying new clothes, but they find shopping is frustrating and